As we continue on, now we're going to take a look at some of the remaining questions, 7 and then 8 and 9 perhaps. So let's think about 7. I've said, given the WACC calculated in number 4 above, what might we say with respect to the discount rate you and your client have chosen? And you can read my text here. You've already done so. But essentially what I'm saying is, look, we're saying this company has a WACC of 7.2%, or excuse me, 8.01%. And that's its weighted average cost of capital. We know that all things being equal, in a market in which we have perfect competition, in which costs will equal benefits so that profit is zero, then we would expect the return on an investment to be equal to the cost of the investment. Well, if we can articulate the cost as the weighted average cost of capital, 8.01%, we would expect the return on the investment to then similarly be 8.01%. However, in this case, the client has chosen a return expectation, discount rate, R, of 20%, way beyond the 8.01% that we're thinking about. So how is it that we might be able to justify a 20% R for the client, but an 8.01% WACC for the firm? Those are rather different. That would suggest that if nothing else was present, that this is a terribly non-competitive market because there's significant profit being driven here, approximately 12%, the difference between the return and the cost. Well, in this case, I think we have to think about this a little bit differently. This may not simply be a function of a non-competitive market. Remember that we calculated all of this WACC based upon these book values of the company's capital structure, but that capital structure now is being driven by the bonds that the new owner, the client, was able to negotiate to help pay off the debt or pay for the negative cash flows for years 1 through 3. So had it not been for the client's ability to negotiate that, which they were able to negotiate that in the market because of their own credit strength, etc., had they not been able to do that, this firm never would have gotten $15 million worth of bonds, well enough $15 million worth of bonds at 7.2%. If it might have gotten them, it probably would have gotten them at 20 or 30%. They would have been usurious because it's a brand new firm that's never created a dime of revenue and clearly was showing that it didn't have the ability to fund the $5 million deficits each year. Yes, it does have some government contracts. It has some future projected cash flows, but those don't even start in the positive for 4 more years. There isn't a company or an investor out there that's going to give that firm that has that structure a 7.2% on $15 million of bonds. So it's your client that helped negotiate that. Plus, the strength of this, its current beta factors, etc., are based on that $10 million investment that your client's making as well. So your client is the reason that this company is able to be at an 8.01% weighted average cost of capital. Since it's the client's credit worthiness, the client's capital, the client's expertise that's allowing for that, then the client is still able to justifiably expect that 20% return on their investment for those contributions. And hopefully that makes sense to you. If it doesn't, then feel free to reach out to me and ask me a little bit further about it, and perhaps we'll talk about this in class even. Let's look at the next page. So I said, okay, fine. Now if we use the newly calculated WACC as the discount rate, then what might those original values have been? So if you look at this, I'm going to switch back now to the spreadsheet. If you look at this, this is a scenario that I've given you in the second set of columns. Here I've given, instead of 20% as an R, I'm using 8.01% as WACC. I'm using the same G's for years 4 through 8, 9 through 13, and 14 plus. But now I've introduced a concept here of a return on investment capital of 13%. I'm going to come back to that in a few minutes. I'm using the exact same cash flows in this scenario I used in the original scenario. I'm using now the same metrics to calculate the discounted present value of each of those cash flows. Note that these amounts now are very different than they were in this other column because the discount rate is very different. And then I'm using the same metrics to simply sum those in this column. And so I get to the point where we end up with a net present value of $31,376,000 plus, as opposed to $789,000, because the rate is so different. All the other metrics I used were exactly the same. I just used a different rate. I plugged it in up here. I then used it in my modeling down here. But interesting, look at IRR. It hasn't changed. Well, the internal rate of return doesn't change, because the internal rate of return is what's the rate of return that we get given these cash flows, assuming the net present value is 0. So what's the return that we get without any extra profit or considerable loss? Well, in this case, the return we get is we would get a $31,376,000 plus return, assuming that we get a 20.6% return, assuming that we have a net present value of 0. So we didn't get 8%, we didn't get 20%, we got 20.6%. I shouldn't have said anything about the numbers in this column. I shouldn't have said the 31 million. I apologize, they may have confused you. So the internal rate of return is the rate of return that this string of cash flows got over those years, assuming a net present value of 0. So what return does this portfolio provide? Notice that in this case, now given the returns and the costs and everything, that we reached a payback or a positive cash flow even in consideration of the costs expected, the WACC in this case. We reached it in year 9. And now think about the present value of the discounted cash flow, the continuing value of the dividend growth, etc. And remember that when we do that, we're not taking into account the investment in year 0. We're trying to give something about just the cash flows that the firm is giving to us now. So to do that, we use the exact same metrics we used before. We simply are using the sum of these cash flows for each of these years, sum of all of these, all the way down to here. And so we're not considering the $10 million investment. So it then took us to $41,376,000. We now use the same equation that we'd used before in the other columns to come up with a continuing value using that dividend growth equation. And we used, of course, now the cash flow in year 14, which was cash flow in year 13, multiplied by the expansion for year 14 of 8%, or 1.08 then, and then we divided that by R minus G, and we have our R and G up here. R minus G, well, R is WACC, so it's WACC minus G, or 0.081 minus 0.08, so not much of a difference there, so we end up with a very, very small denominator, and that then leaves us with a very large value of 204 billion plus. Now, when you're trying to replicate these numbers on your calculator, you may have come up with a number that's several $billion off of this because of rounding differences. I'm not going to say rounding errors, I'm just going to say rounding differences. When I put this through through my calculator, or when I put this through Excel, it picks up the entire string of any values that are calculated all the way through the nth decimal point, whereas you probably use only to 2 decimal places or maybe 3. So that's going to yield, after this much time, and these values that are this large, is going to yield some number differences here. We're now going to take that value, discount it back to present day, utilizing the WACC as our R factor, and so we end up with almost 75 billion, and then we're going to take that 75 billion, or 74,975 plus 41,376, and it'll give us 75 and 16, and then some other digits here, $75 billion plus of value for this company. That's a big value. And you might then see why an investor might be interested in putting some of their capital at risk to get that kind of a value. Well, that's using the dividend growth equation. So as we look a little bit further, we can say, okay, how might this have been different? How might we reconcile the value you assigned previously, previous to making the offer, to the values now? So let's go back and see, we assigned this $26,538,000 value originally based upon a 20% opportunity cost. Here we're assigning a $75 billion value based on an 8% WACC, or using that as a proxy for opportunity cost. How might we think about those differences? Well, those differences are because 12% over 13 years in the kinds of numbers we're talking about is a big, big difference. And so we're going to be able to reconcile that based upon that. You can look at some of the comments that I've made here, but also I'm giving comments here about our original net present value, and I'm giving comments about this issue of the dividend growth equation. You might recall, hopefully you recall, from your classes, your Finance 300 class, the dividend growth equation gives us some value at time 0 being equal to some income. I'm going to call it cash flow now at time 1 divided by, I'll call it WACC minus G. Well, if we think about that, this value would be negative if WACC was smaller than G. If G is larger than WACC, this would give us a negative value. So we only get consistently positive values with this kind of structure when G is less than R, or WACC is less than, or G is less than WACC. Or the other way of saying it is WACC is greater than G, or R is greater than G. So that would be a limitation of the dividend growth equation. We'll talk about that more in class in future weeks. So now as we move down to item 10, see, we'll do this. I ask you to prepare a valuation for the firm based on its cash flows, WACC, but now using the key value driver. Many of you that took Finance 300 from someone else may not have explored the key value driver model. In my Finance 300 classes we do. So let's spend a few minutes talking about that. We'll go back to the spreadsheet. The key value driver model is only going to affect our calculations of the continuing value and of the present value of the continuing value, because the key value driver model uses a equational structure that says value in its entirety is equal to the sum of the discounted cash flows, the cash flows for the various periods I, divided by 1 plus R to the T. Well, those are our discounted cash flows that we see in this column, the sum of those, plus then some continuing value. And the continuing value, when we use the KVD structure, is equal to whatever cash flow we're using times, whatever cash flow we're using times 1 minus G divided by ROIC, return on invested capital. Well, my handwriting's terrible on this, I'm terribly sorry. But 1 minus G divided by ROIC divided by WACC, I'll just say W minus R. My interface with this tablet when I'm doing it over Excel is not very good. I apologize that this is so terribly, this is so not neat. On some of my other videos I'll try to make this better for you. But the cash flow that we're using, in this case, the cash flow at period 14, which is cash flow 1 in the way that we're thinking about it, divided or times 1 minus G divided by ROIC, all of that divided by WACC minus, I said R, it's minus G, WACC minus G. And that is the key value driver equation. The key value driver equation, and you can see this better in the, well, I guess I don't actually show it to you here. I apologize. I thought I'd shown it to you in this story. Let me try to write it out for you again. The key value driver equation is going to be value the value is equal to the sum of our discounted cash flows divided by 1 plus R to whatever our time component is, plus then the continuing value of the KVD, and the continuing value of the KVD was equal to the cash flow that we pick up for the next time period times 1 minus G divided by ROIC, and that divided by WACC minus G. That's the key value driver, which suggests that the key drivers to value are cash flow, growth, cost of capital, and return on invested capital. We're going to be talking more about this in future sections. Hopefully you discussed return on invested capital in your Finance 300 courses. So in this case, if we apply those equations, it doesn't change IRR, it doesn't change net present value, it doesn't change the payback period, because all of that is within the discounted cash flow period. It's not within the continuing value. And the key value driver model is exclusive to the continuing value. But now we come up with a new continuing value. We discount it back to the present using that WACC, or R in this case, of, I believe it was 0.0801, and it then gives us a overall value of $28,878,000,000 and some change. So that's how you come upon these values. And then finally, I'm saying, how is it the firm's return on invested capital of 13% makes such a significant difference? That is the one variable that we're now using in the key value driver model that we didn't use when we assessed this with just a discounted cash flow plus the dividend growth model. So how is it make such a difference? Well, it is a far more accurate assessment than the dividend growth model gives us, because I think we would all agree that the return that firms get is a considerable factor in identifying their value. Think about this. If the return a firm gets is less than the cost the firm gets, then the firm actually is losing money. Well, we didn't have the return component in the dividend growth model. Introducing it into this model is a big deal. Introducing it kind of moderates this overall value, because the return of 13% is only slightly greater than the cost, the WACC of 8%. Without using the return, then you don't have a limit there, and so the dividend growth equation is not as satisfactory. And if you actually read through my notes here, you'll find that the dividend growth model only gives you consistently positive results, assuming you have positive cash flows in the aggregate. It only gives you consistently positive results when R is greater than G, or WACC, if that's what you're using, is greater than G. The key value driver model, though, because it's a little bit more complex, only gives you consistently positive results when G is less than WACC, is less than ROIC, or when return on invested capital is greater than WACC, which is greater than G.